Okay. So what have we been doing up to this point? We did some intro stuff, Git, making, so we did some kind of C code, make, CMake, a bunch of Python stuff. And now this week, kind of the last week, I guess, of the kind of the general bootcamp track. And so what we're kind of getting into more this week is really how you play nice in bigger software projects. Okay. Okay, so let me ask you this. I mean, you is that my computer clicking around? No.
That's me.
Okay, that's fine. Sometimes I get all sorts of pop-ups. Okay, so I mean, as you become part of larger and larger software teams, and you can think of big software teams with tens or hundreds of people, how do you make sure that as you everyone's making pull requests and merging in their code, how do you make sure it still works? I mean, how do you make sure there's not bugs? I don't know, what approaches have you used in the past, or what do you think people use? Sheer luck. That might work with 2 or 3 of you, but it quickly breaks down. We could pay someone. We could have someone be like a tester, and we hire them on our team, and they just keep doing git clone, building and running our code, and running all these test programs all day long. And when you commit code, they just do it over again, and that's just all they do all day long. How else could you do it rather than that?
GitHub tests.
Yeah, GitHub tests. Yeah, we'll talk about that in a sec. Yeah.
See if there's like compiler errors or anything like that to like sort out the big problems.
Okay, having a computer do this, right? So that's when I was a student, when I was a grad student, that's kind of, we'd run code like this on we'd have some dedicated computer that would just be doing this, okay? It would like watch our Git repository, or back then it was SVN, and anytime there's a change, it would clone stuff and build it and check it, and even post it on a nice little web page for us to look at, okay? But these days, as things move more and more to the cloud, we kind of use cloud services to do these types of things for us. Okay, and so we have really leveraging cloud compute to basically constantly check our code and make sure that it still works correctly. Okay, so let's see, let's go look at, maybe this isn't a great example because there's no open pull request. Let's see, let's find one that's closed on the computing bootcamp. Okay, so maybe you've seen this when you created a pull request, okay, to add in the link to your page to the computing bootcamp. You'll notice it ran some checks, okay? Before you could actually merge in your code, it ran some of these checks, okay? And so on the website, if I kind of expand, let's see. It basically was trying to build your code, and we have another one called check links. And that would make sure that you didn't commit some broken HTTP link into the website. Because personally, I mean, I didn't have this until a month ago when you all started creating pull requests, and I'm like, I don't want to like check the website and make sure that you're not committing broken links every time. And so I set this up to just do it automatically for me, okay? And so as you work on larger and larger software projects, you're gonna see this automation set up, or maybe you will get to be the ones to set this up. So how does this magically work on GitHub, okay? This is just one system. If you use something like Bitbucket instead, or you could use other services out there, there's lots of different services, okay? But this uses what's called GitHub Actions. And so if I go into, you'll see in the website, there's actually a .github folder. And it's in workflows, okay? And in here, in workflows, any little YAML files I put in here, this tells GitHub, hey, when I push new code in online, I want you to go check if there's kind of little server side things for you to do, okay? So one of them, these names aren't important, aside from your own purposes, I've called build and check, okay? And different systems have different formats, okay? And you could go read the documentation about how to do this for the GitHub system. There's other things out there like Travis, but these days more and more stuff is being done with the GitHub Actions, okay? And so what this says is, hey, this is when you should run this. Anytime someone pushes or when they create a new pull request, I want you to do this. And I'll make this bigger here. And what it does is it says, hey, okay, what is this going to run on? This doesn't run on your computer or my computer, okay? I'm not going to spend the time to set up some script on my own computer that clones stuff and I have to make sure it's working. That's way too much work, okay? GitHub has kindly donated, or I guess Microsoft has kindly donated server time we have with education credits. So often you would have to pay for this type of thing. It's free if your project is open source, but we can do it even with closed source projects. It says go get the latest version of Ubuntu. So in GitHub land, that means go spin up an Ubuntu 20 virtual machine. And so in some Azure cloud around the world, when I push my code in, this virtual machine spins up and starts to do these things. So this says it uses, basically it's using some other little script that someone's made, and this is actually made by GitHub, but it really just clones my code, okay? So first thing it does is it gets your code and clones it onto the machine. And then I say, I kind of give it a name, I'm calling this build, okay? You'll notice I had two things, right? Build and check links. This one's build. It says you must run all of these commands and they must run successfully. So first thing I go do is I cd into the website folder, if you remember doing that, and then maybe that should be lower down here, but it doesn't really matter. I go and I have to get some packages. I'm essentially just installing Jekyll here or bundler and do a bundle update just like you did, but it's doing it on the machine. And then I run make build and make sure it succeeds and the website builds, and that's done automatically. Every time someone makes a new pull request, it spins up a new virtual machine and installs packages, and maybe it wastes a bunch of electricity, but this saves people time and make sure that things are always working. Yeah.
Are we recording this lecture?
Yeah, we are. Okay, and you'll notice my check links one looks quite similar. Okay. And from seeing this, I hope you understand that they're independent, okay? I could have run make build and run make check links, okay? And it would run it on one virtual machine, one step after the other. But I decided, hey, we've got enough free minutes with Microsoft here. I'm just gonna spin up essentially two machines, and it's gonna run both of these at the same time on two different machines, okay? And so you kind of, all your testing can be done essentially in parallel, which is quite nice. And so I'm not going to go through, you can read documentation about how to make files like this. But I just wanted you to understand what's really going on when we do these things. Yeah.
This is GitHub Actions.
Yeah.
This is not the same as Travis CI.
No, Travis CI is like almost the same, but.
But they're okay. That's why I asked, because on some previous web pages using Jekyll, you had set up Travis CI.
Yeah.
And I just wanted to make sure that I was tracking. This is different. This is the alternative.
Months ago, Travis CI, maybe they were purchased or something, and they kind of went dark and stopped supporting academic projects for a few months. And so we just moved to GitHub where we had free credits. And then they send me an email a month ago saying, hey, just getting back to your request from 6 months ago. We can give you free credits now. And it's like, too late, we're done, we're gone. So, so on GitHub, your project for you will have to be open source, but if it's under something like BYU CCL or your NetLab GitHub that has academic access, you'll also have credits for private projects. Yeah. It involves using a YAML file. The syntax is slightly different, but largely you're doing the same steps. It took me about 5 minutes to move between the two for a small one like this, but I'll show you a much bigger one that would take a lot more effort. Yeah.
Just because, so I like make build and make checklists. Is that like you have a separate like make file for each of those that is then run?
No, these are ones you could run when you do the website. Let's see, did you go through it? You typed make serve or something like that? Or you didn't try it locally? Okay. No, these are just my own make file. If we go into the code. No, this is just my code. It's just like if I ran these commands on my own computer. It's just running my build and my check links from my make file. Okay. So you can make, it doesn't have to be make. I could run a Python script. I could run a bash script. I can run a sequence of scripts, whatever you want to do. It's just like running those commands in the shell. So any other questions? Let's go look at one that's more complicated. Okay, so also you may notice when you commit things, you get a little green check mark here or a red X. That's essentially whether all those actions succeeded or not. Yep. I only know how to call things to check if they fail or not. So in Linux world, that means whether the program exits with a 0, success, or non-zero. Maybe it has fancier things that I don't know about, but you can always write some wrapper bash or Python script that checks whether something is equal to something and then returns a 0. Okay, so if I click on this, you'll see, hey, whoa, there's lots of tests. Let's go look at one of these. Okay, so I'm gonna try and, so this is neat. This is a fancier one. I'm probably not gonna jump into the YAML and look at all of it, okay? But they have lots of tests here, and you'll see that a lot of them can be run in parallel. So GitHub parses your YAML and then builds a nice little graphic for you to see, okay? And some can depend on other ones. Say, I only wanna run this if all the other ones succeed and things like that. You can do fancy stuff. But just to give you an idea of some of the things we might do with a more commercial grade project, okay? So they have a category they call compatibility, okay? They're compiling the code with GCC version 5, 6, 7, 8, and 9, plus Clang 6 and 8. So lots of different compilers. That's what's breaking right now, okay? So they're testing compiling with all these different things. They're running auto formatters, okay? So you'll see sometimes when I save my code or in 330, we use auto formatters, okay? We're running a C auto formatter, we're running a Python auto formatter, and a Python linter, okay? And we're checking essentially that whoever committed the code ran those things, okay, before they checked it. And we won't let anyone check in code that hasn't run those things. So then there's another category here called regression. This is actually kind of running our software on different test suites to, yeah.
These categories are what the people on this project created in their YAML file.
That's right, yeah.
These aren't canned things
No.
that GitHub knows about.
No, is just what they made, but just so you can kind of see the types of things that go on big projects.
Well, I want to point that out that, yeah, there's no reason you can't group them and give them titles and the whole bit. So it's easy to tell which part of your testing failed.
Yeah, so then here they run it. They're just running their actual software, and I won't get into this. This is open source FPGA CAD stuff, but they're just running their software on lots of different workloads. There's another one here called sanitized. Does anyone know what it means to run sanitizers? It compiles in extra things into your C code to make sure that you're never go wandering in memory you shouldn't be. So it wraps calls to malloc and free and things like that, and your pointer dereferences. It's kind of like Valgrind if you've used that before, but it makes sure that you could never, luckily not segfault. So it makes sure you're always doing memory references inside of bounds. So your program runs a lot slower when it does all this extra checking, but hey, we throw it up in the cloud. This thing, I think, takes like 2 days to run. But it's all good. So then a bunch of other little tests building it. And here's this W1. We've just named it W. It's making sure that it compiles with no warnings. We will not accept code into the code base that produces warnings when it compiles. So all sorts of different checks that you could choose to incorporate into your project, make sure that when your neighbor pushes code in, they don't screw it up and make it worse. So, okay, anything on this? I don't have any examples, or we're not really going to mess with it. I just wanted you to see what it was. Okay, so one of these things that was run, you'll see it says unit tests. Okay. And so what we're going to talk about kind of for the rest of today is about unit tests, and I'm going to talk about it in Python, and Dr. Mangelson's going to talk about it in C++. But what it is about writing test programs. So you'll see, I mean, if you want to do all this infrastructure, some things are nice. You can check that your thing builds and try different versions, but at some point you want to run your code and make sure that it does what it's supposed to. And while you might run the whole software suite, often we want to just check individual functions or individual pieces of our code and to make sure they are doing things correctly. So all this infrastructure is only as good as the test code that you write. Okay, and so often when I've done work actually specifically for this project, I have found a bug. Okay, and I think, oh, I'm going to be really nice and go patch this bug, fix it, and commit it in. So I create a bug. Don't create a bug, sorry. I create a fix for the bug. I create a pull request, and I go, oh, this is great. They're going to accept my pull request. And they come back and they say thanks, but now we want you to go create a test so that in the future this bug can't be reintroduced. So go write some new test code. Then go update we call this all continuous integration, or CI, if you've heard that term. They say, go update the CI test so that it runs your test code so that this bug can never happen again, okay? And so really fixing the bug was only like 30% of the work. The other 70% was updating the test infrastructure so that we knew this bug could never happen again. So let's look at how we do that in Python, how we write test code.